probably the most important part. A normal distribution is a bell-shaped symmetric distribution. Oops. So we only use this rule for mostly symmetrical situations with tails on each end. Those tails are just this sort of shape. Okay. A normal curve has the following properties. About 68% of the data will fall within 1 standard deviation from the mean. Okay, I'm going to look back over here at our box plot. We don't have the mean, but I'm assuming because it's symmetric, it's somewhere around the median. So I'm just going to label that just so you guys can see. You do not need to label yours. About 68% of the data will fall within 1 standard deviation from the mean. Oops, I didn't calculate the standard deviation over here. That's fine. Whatever our standard deviation is, let's say that it's 2. I would add 2 to get this next number. So that would be 13. I would subtract 2 to get the number of a 4, which would be 9. 68% of the data will fall within the area from 9 to 13. That's what the shape of this bell curve is saying. Our next rule is that about 95% of the data will fall within 2 standard deviations from the mean. 95. The top one is 68. The middle one is 95. So then I would just go another standard deviation out on both sides. Saying our standard deviation is 2. So that means 95% of my people's test scores are between 7 and 15. If we go 3 standard deviations out, so that would be between 5 and 17, then I would have 99.7% of all of my test scores are going to be within there. After that, there's just about like 0.3% of people left on, 0.15% of people left on either side. We'll see what I'm talking about when we do the next problem. I'll leave this here for a second for anyone who's still writing it down. About 68% of the data falls within 1 standard deviation from the mean. If we go out 2 standard deviations on either side, we get 95% of it. 3 standard deviations, we have almost everybody. Okay. So here, they give us this nice little curve. I'm going to cross out some of these numbers that we're going to use. People use different estimations. The ones that we're going to use, 34 and 34, 13.5 and 13.5, 2.35, 2.35, and then 0.15, 0.15. And these are all percents. So what's happened here, we took 68% of our data will fall between 1 standard deviation from the mean. We just split that 68% into 34% on each side. Then we looked at the 95%. We subtracted the stuff that was already in the middle at 68%. So if I do 95 minus 68, I get 27. And we just split that evenly between the 2 sides to get 13.5% on both sides. And then so on with the 2.35% and the 0.15%. Okay. So a few things that we can answer from this graph. What is the mean? The mean is the number in the middle. If it's symmetrical, the mean is the number in the middle. So our mean is an IQ score of 100 points. So the IQ score of adults is normally distributed as seen in the graph below. So we can say that this is the mean right in the middle because they're normally distributed. What is the standard deviation? Well, we talked about 68% of the data will be within one standard deviation to the left and to the right of the mean. So what I can do, I can just pick one side. I'm not going to look at both. I'll just pick this one. 85 is one standard deviation away from the mean. So if I subtract the two, I take the mean and I subtract a number that's one standard deviation away, I will get my standard deviation. I get that my standard deviation is 15 points. So I'm doing not a lot of math here, not a lot of calculating. I'm just reading the graph. Then it asks me, between what IQ scores do 95% of adults have? Okay, that's worded in a weird way, but that's fine. We can figure it out. 95% of adults. So they've got this thing nicely labeled for us. 95% is in between a score of 70 and 130. Perfect. So 95% of adults' IQ scores will be between 70 and 130. The top 0.15% of adults have what IQ score or above? So see if you can figure that out. Or do the top 0.15% of adults have? Here's our 0.15%. I just erased it over here. The top 0.15% of adults are scoring 145 points or up. So I can just write 145 plus. Anything above that is the top 0.15% of scores. What percent of adults have an IQ score of less than 115%? You can try this. It can get kind of complicated. I'm looking at 115 right here. And I want to know what percent of adults have that score or below. Depends on what numbers you use. If you use the ones on the screen or not, it is about, oops, what did I write on here? Yeah, it's about 84%. If you got a decimal off, that's fine. But what we're doing is we're adding all these areas or these percentages that are below the score that we're looking at. So 115 or below, 34 plus 34 plus 13.5 plus 2.35 plus 0.15. You get somewhere around 84% when I add all of those together. We're going to move on to the last question. Perfect timing, actually. Draw and label the distribution. Okay, so this time they just give us a few pieces of information and we have to make that whole chart ourselves. So this is something you have to memorize, these percentages and how they break down. The scores of Math 1 students are normally distributed with a mean of 74 and a standard deviation of 8. Okay, we said that the mean was in the middle on a normal curve. Oops, so 74, our mean, will go in the middle. To go up or down a tick mark, I'm going to add, if I'm going up, or subtract if I'm going down, the standard deviation each time. So if I want to find the mean plus 1 standard deviation, I'm going to do 74 plus 8. And I get 82. If I want to find the mean minus one standard deviation, I do 74 minus 8, and I get 66. Okay, so within here, from the mean to one standard deviation below is 34% of my data. And same thing with above. Now I'm going to go and do my second standard deviations on both sides. So again, I'm just going to add a standard deviation up here. 82 plus 8 will get me 90. 66 minus 8 will get me 54. Oops, nope. 58. In between 58 and 66, so in between 2 and 1 standard deviations, I'll have that 13.5 number. In between 82 and 90, I'll also have 13.5%. I'm going to go my third standard deviation now. This is going to be 50. Oops. And this is going to be 98. In between there, I have 2.35% on both sides. And at the very ends, from 98 to the end and 50 to the end, I have 0.15% on both sides. Okay. Find the percent of students whose score is between 66 and 90. Find the percent of students whose score is between 58 and 74. Find the percent of students whose score is less than 90. And find the percent of students whose score is more than 58. So see if you can add all those percentages together. Find your totals for each question. All right, who's got part B? 81.5%. That's 34 plus 34 plus this fifth. Oh wait, where are we going? 66 and 90. 34 plus 34 plus 13.5 will get us 81.5. For finding the percent of students who score between 58 and 74, I would add up all these chunks between 58 and 74. So that's just 13.5 and 34%. We'll get 47.5%. I'm going to add up for finding a percent of students whose score is less than 90. I'm going to add everything that's less than 90, everything to the left of 90. I add all of that up and I get 97.5%. I can also find the percent of students who scores more than 58% by finding everything, adding it up, everyone who scored more than 58%. I also get 97.5%. If you think you can do this faster by subtracting things from 100%, totally fine. If you want to add everything together, that's also totally fine.